students, welcome back. In the previous session, we have seen about all the details about Henry's law. Okay, what is Henry's law? What are the applications of Henry's law, limitations of Henry's law, effect of temperature and pressure on Henry's law. Today we are going to see numericals based on Henry's law from NCERT in text and exercise. Okay, so let us start very quickly. H2 is a toxic gas with rotten egg-like smell is used for qualitative analysis. Okay, there is a gas which is your hydrogen sulfide gas. Okay, it is a toxic gas with rotten egg smell is used for qualitative analysis. If the solubility of H2S in water, so we are what are we doing? We are taking hydrogen sulfide gas and we are passing through water. If the solubility of H2S in water at standard temperature and pressure condition is 0.195 molar, okay, calculate the Henry's law constant. Okay, here we have taken a gas, H2S toxic gas, and it has been passed into water, and he has given the solubility of H2S in terms of molarity, concentration term, and asking to find out Henry's law constant. Now, what is the only formula we have for Henry's law? From that only we can get anything, am I right? We don't have like 4 to 5 formulae for Henry's law so that we can try this and that formula. Okay, we have only one formula. What is that formula? Pressure of gas is equal to, okay, pressure of gas is equal to, okay, kH into mole fraction of gas. Okay, pressure of gas is equal to kH into mole fraction of gas. This is the formula. So here which gas we have taken? We have taken H2S gas. So pressure of H2S gas is equal to Henry's constant into mole fraction of what is the gas we have taken here? H2S gas. This is the only formula we have. So what is he asking? We need to find out Henry's constant here. Okay, we need to find Henry's constant here. So I am rearranging the equation. Henry's constant is equal to pressure of H2S gas divided by mole fraction of H2S gas. Now what is given in the question? Solubility of H2S in water at STP is 0.125 molar. Calculate Henry's law constant. Okay, so we have okay, here he has mentioned STP conditions. So what can I take pressure as? Okay, pressure of H2S gas I can take here as what? 1 bar. Okay, why am I taking it as 1 bar? Because here he told us it is STP condition, so I can take pressure as 1 bar. Okay, so this is fine. I have pressure of H2S. So what else do I need here? I need mole fraction of H2S so that I can find my Henry's constant. Now, we have to find the mole fraction of H2S. Now, how to find mole fraction of H2S? Mole fraction, what is the formula for mole fraction? Mole fraction of H2S is equal to number of moles of H2S, divided by total number of moles. So it is a solution in which I have gas is my H2S gas, and into water we are passing H2S gas. So what is my other component? It is my water. Okay, divided by number of moles of H2S plus number of moles of water. Okay, number of moles of H2S plus number of moles of water. Here do I have number of moles of H2S and number of moles of water directly given for us? No. So first let me find out number of moles of water. Okay, first let me find out number of moles of water. Number of moles of water is equal to weight of water divided by, okay, divided by molar mass of water. Okay, and in the similar way we can find out, okay, number of moles of H2S also. But what information do I have to find number of moles of H2 or number of moles of H2S? Nothing I have. Because I don't know the mass of water, because it is not given in the question. I don't know the mass of H2S. Okay, so that I can find out the number of moles. But here, okay, we'll keep this on hold for some time. Okay, because we don't have any data needed to solve this here. Okay, let us go back and see the term which is given to us. Okay, let us go back and see the term which is given to us. He told solubility is, okay, what is mentioned in the question? Solubility is mentioned in the question. So solubility is equal to 0.195 molar. Now, when I was teaching molarity, I explained you how to understand molarity. Now, when I say 0.195 molar, what does it mean? 0.195 moles of, okay, solubility of what is given? H2S gas is given. Okay, 0.195 moles of H2S gas in 1 kg of water. In what? In 1 kg of water. This information I have from here. Okay, this information I have from here. So what can I write from here? Number of moles of H2S. Okay, number of moles of H2S is equal to 0.195 moles. Yes, number of moles of H2S is equal to 0.195 moles in 1 kg of water. So I have what? Weight of water or mass of water here. Weight of water is equal to 1 kg, that is equal to 1000 grams. Okay, 1 kg, that is equal to 1000 grams. Now what can I do here? Okay, number of moles of H2S I directly got here from the solubility term given. Now you might be getting a doubt, when I was teaching Henry's law, I was talking about solubility is equal to mole fraction. But here he didn't give solubility in terms of mole fraction, he has given solubility in terms of molarity. It is fine. I told you how to, no, you should be able to convert one concentration term to other concentration term. By expanding it and writing it, you will get lot of information. That information we will use to find other concentration terms. So that is what we are doing here. Now number of moles of H2O is equal to, now how can I find out the number of moles of H2O? Number of moles of H2O is equal to weight. What is the weight of H2O? Okay, 1000, okay, divided by, what is the molar mass of H2O? 18. 1000 by 18. I told you in the previous sessions only, this value you have to remember because it keeps on coming repeatedly in many chapters. So this value is equal to 55.55 moles. What is this value? 55.55 moles. So this is a standard value. Usually they will give 1 kg of water only, so you can remember this. So number of moles of water is equal to 1000 weight of water, given mass of water, divided by molar mass of water, that is equal to 55.55 moles. So I got number of moles of water. I already have the number of moles of H2S which I got from the molality term. Now what can I do? Now I can happily find out mole fraction of H2S is equal to number of moles of H2S. How many number of moles? 0.195 divided by, okay, divided by number of moles of H2S 0.195 plus 55.5. Okay, plus 55.5. Now we need to add the denominator part. 0.195 divided by 0.195 plus 55.5 comes to 55 point, how much? 745. Okay, 0.195 divided by 55.745. Here decimal point, after decimal point 3 numbers, after decimal point 3 numbers. So I can ignore that. So mole fraction of H2S is equal to 195 divided by 55745. Okay, which will be equal to, okay, if you solve it, you will get it approximately equal to 0.0035. So what is the mole fraction of H2S we get in the question? 0.0035. Now I got the mole fraction of H2S. I can go back and find out my KH value. Okay, what is KH formula? Here I have pressure of H2S already. Okay, we know the pressure of H2S because he has given the condition as STP condition. So pressure of H2S divided by mole fraction of H2S. So that will be equal to what? Pressure is 1 bar divided by, what is the mole fraction of H2S here? 0.0035. So this I can write it as, so here this will become 35 divided by 10,000. So I can write it as 10,000 divided by 35. Okay, 10,000 divided by 35. Now if you calculate this, you will get the value as approximately 285.7. Okay, 285.7 will be your answer. So this is how we have to solve this question. Pressure of the gas, pressure of H2S gas, I got it from STP conditions as 1 bar. We need to find Henry's constant. Now my task here was to find out mole fraction of H2S. Mole fraction of H2S is equal to number of moles of H2S divided by number of moles of H2S plus number of moles of water. You know mole fraction formula. Okay, mole fraction of that one component divided by total number of moles of all the components present in the mixture. Now I didn't have any information to calculate the mole fraction of H2S, so I used this solubility term he has given 0.195 molar. It is not always compulsory, he will directly give the mole fraction term, so you can convert one concentration term to other concentration term. From this, how did I write this concentration term? 0.195 moles of H2S gas in 1 kg of water. Okay, then number of moles of H2S, how much it is? From here I got 0.195 moles. Weight of water is what? 1 kg, which is equal to 1000 grams. Now from this information I have found out number of moles of water, 1000 by 18, which is 55.55 moles. From there I have calculated mole fraction of H2S. Okay, by using this formula I have calculated, and I got mole fraction as 0.0035. Now I know the formula. Henry's constant is equal to pressure of H2S gas divided by mole fraction of H2S gas, 1 by 0.0035, which comes to 285.7. Now let us solve the next numerical. Henry's law constant for CO2 in water is 1.67 into 10 to the power of 8 Pascal at 298 Kelvin. So we have CO2 gas which is passed into water. So my gas is CO2 and my liquid is water. So you know when CO2 is passed into water, you get your soda drink or cold drink, all those. Okay, so he has given Henry's constant. What is asked in the question? Calculate the quantity of CO2. We need to calculate the quantity of CO2 in 500 ml of soda water. Let us understand this statement. Now, CO2 has been passed into water, so it has become soda water. Now, we have 500 ml of soda water. We have 500 ml of soda water with us. In 500 ml of soda water, how much quantity of CO2 is there? Okay, now when CO2 has been sent into water and soda water has been made, it will be under certain pressure. No? I was explaining in the previous session. When you pass CO2 into water, so now CO2 should stay in the water, so it will be under certain pressure. Now here, how much pressure it has been packed under? It has been packed under a pressure of 2.5 atmospheres. So we need to calculate the amount of CO2 in 500 ml of soda water, which is packed at a pressure of 2.5 atmosphere at 298 Kelvin. Okay, so ultimately we need to find quantity of CO2. Now whatever data is given, let us write down. Henry's law constant is given to me, which is 1.67 into 10 to the power of 8 Pascal. Fine. Calculate the quantity of CO2. Okay, so we need to find out mass of CO2 or weight of CO2 here. Okay, in 500 ml of soda water. Okay, 500 ml of soda water. So here I can take this as volume of solvent. What is the solvent here? Water. Okay, because soda water. Okay, if CO2 has been passed, so ultimately it will be volume of water only. Volume of water is equal to 500 ml, because see, as such CO2 will not create separate space and increase the volume of water, right? So whatever volume of soda water is there, I can take it as volume of water, which is 500 ml. Now it has been packed under 2.5 atmosphere CO2 pressure. So pressure of CO2 is given for us, which is equal to 2.5 atmosphere. Now the problem is here we need to do a conversion because we usually take in pascals, and already Henry's constant is there in pascals. So let us convert atmosphere into pascals. How do you convert atmosphere to pascals? We can convert atmosphere to pascals by multiplying with 101325. Okay, so 2.5 into 2.5 atmosphere into 101325 will give us pressure in pascals. Clear. So we have Henry's constant, we have pressure of carbon dioxide gas, we have volume of water. So what is the formula we have here? Okay, the only formula we have from Henry's law is pressure of gas is equal to Henry's constant into mole fraction of gas. Now here, what is the gas I have? CO2 gas is equal to Henry's constant into mole fraction of CO2 gas. This is what I have. Now I have pressure of CO2 given in the question. Henry's constant is given in the question. Now I will obviously find mole fraction of CO2. But did they ask mole fraction of CO2 in the question? No. They have asked for quantity of CO2. But if you know the mole fraction of CO2, you can know the moles of CO2. If you know moles of CO2, then obviously you can find mass of CO2. So we'll do it in that way. So first let me find mole fraction of CO2. Now if I rearrange the equation, I can write first we need to find mole fraction of CO2. Okay, CO2, right? So mole fraction of CO2. So please rearrange this equation. Pressure of CO2 divided by Kh, which is my Henry's constant. Now mole fraction of CO2 is equal to, what is the pressure of CO2 here? 2.5 into 101325, because we have converted atmosphere into Pascal, divided by 1.67 into 10 to the power of 8. So here you have Pascal. Okay, Pascal in the numerator and denominator, so the unit will get cancelled. Okay, So this is how you can calculate the mole fraction of CO2, because you already have the pressure of carbon dioxide and Henry's constant. Now if you do this calculation, solve it, or they solve the calculation accordingly, you will get it to 1.517 into 10 to the power of minus 3. So mole fraction of CO2 will come to 1.517 into 10 to the power of minus 3 will be the mole fraction of CO2 if you do this calculation. Now when you have the mole fraction of CO2, what can I do? See, you people know mole fraction of CO2 is equal to number of moles of CO2 divided by number of moles of CO2. What is the other component I have in the solution? The other component I have is number of moles of H2O. Okay, number of moles of H2O. Now, I have mole fraction of CO2. Okay, now if you see this equation, I'll tell you something here. I have two components in the solution. I have my number of carbon dioxide and water. Now, what exactly happens here is, now when you compare what number of moles of water and number of moles of CO2, when you pass CO2 into water, compared to the amount of water, water is a solvent which is in larger amount, compared to the number of moles of H2O, compared to the number of moles of H2O, number of moles of CO2 is very, very, very less. Now, when we know that number of moles of CO2 will be very, very, very much less than number of moles of H2O. Now, can I ignore that term in the denominator? Because if the term is very, very, very small in magnitude, and it is there in the denominator, it doesn't make much difference to our final answer. It doesn't make much difference to our final answer. So I will ignore number of moles of CO2 from the denominator. Okay, then my formula comes to be mole fraction of CO2 is equal to number of moles of CO2 divided by number of moles of H2O. Now taking this forward, what did I write here? Number of moles of CO2 is equal to mole fraction of CO2 is equal to number of moles of CO2 divided by number of moles of H2O. Now let us see, do I have number of moles of CO2? Do I have number of moles of H2O? Number of moles of CO2 I don't have. That is what we started, and we need to find number of moles of CO2 so that we can get mass of CO2. Do I have mole fraction of CO2? Yes, I have. Do I have number of moles of water here? Okay, do I have number of moles of water? I don't have number of moles of water, but I can try finding out number of moles of water. Am I right? I can try finding the number of moles of water. Now, number of moles of water is what? Weight of water. Okay, weight of water divided by molar mass of water. Divided by molar mass of water. Now, do I have weight of water, mass of water? I don't have mass of water, but I have volume of water. You people know density of water is 1. Density of water is 1. Now if you see, density is equal to mass by volume. For water, density is 1. So, okay, mass divided by volume is 500 ml. So mass will come to how much? 500 grams. Because density of water is 1. Okay, density 1 is equal to m by 500. So mass will come to how much? 500 grams. So here I got my weight of water to be 500 grams, and you people know the molar mass of water is 18. So I got my number of moles of water. I got my number of moles of water. I have my mole fraction of CO2 already. I already got it. So if I do cross multiplication, number of moles of CO2 is equal to mole fraction of CO2 is how much? 1.517 into 10 to the power of minus 3 divided by 500 divided by 80. Okay, 500 divided by 80. Now if you solve this, okay, if you solve this, you will get your number of moles of CO2, which will come to 42.14 into 10 to the power of minus 3 moles. Okay, so first I have found out the mole fraction of CO2, which was 1.517 into 10 to the power of minus 3. Now using mole fraction of CO2, I have found out number of moles of CO2 because I already have information to find out number of moles of water, which came out to be 500 divided by 18. Now I have number of moles of CO2. I can find mass of CO2. Number of moles of CO2 is equal to mass of CO2 divided by molar mass of CO2. Now if I do, what is molar mass of CO2? What is molar mass of CO2? It is 44. Molar mass of CO2 is 44. If you want, you can check. CO2, carbon is 12, oxygen is 16. So 2 oxygen, 16 to 32. So molar mass of carbon dioxide is 44. So let me substitute. Mass of CO2 is equal to number of moles of CO2 into molar mass of CO2. Okay, number of moles of CO2 is how much? 42.14 into 10 to the power of minus 3 into molar mass is how much? 44. Clear? Okay, number of moles I already got here. Molar mass you should be knowing, or else you can write the atomic masses of individual atoms and calculate. If you calculate this 42.14 into 10 to the power of minus 3 into 44, the mass would come to be 1.854 grams. So what is the mass of CO2 here? Okay, what is the mass of CO2 here? Mass of CO2 is 1.854 grams. So what is the quantity of CO2 present in 500 ml of soda water? How much quantity of CO2 is present in 500 ml of soda water? It is 1.854 grams of CO2 is present in 500 ml of soda water. So what did I do? Henry's constant was given. Okay, volume of the solvent water was given. Pressure of CO2 was given. What did I do? First, I found out the mole fraction of CO2. First, I found out mole fraction of CO2 by rearranging the equation. Pressure of CO2 divided by Henry's constant. Okay, using that, I got mole fraction of CO2. So then I have used mole fraction of CO2 is equal to number of moles of CO2. In the denominator, I have ignored number of moles of CO2 because it's a very smaller term. Being in denominator will not make much difference to my answer. Divided by number of moles of H2. When I solved it, I got it to be 42.14 into 10 to the power of minus 3 moles. Now when I got the number of moles of CO2, it was very easy for me to find the mass of carbon dioxide present in 500 ml of soda water. So this is an NCERT question. Hope you understood. I did it step by step. Okay, now we'll do one more question from NCERT. Let us see the exercise question on Henry's law. The partial pressure of ethane over a saturated solution containing 6.56 into 10 to the power of minus 3 grams of ethane is 1 bar. Okay, first let me explain what is he trying to tell us in the question here. The partial pressure of ethane, now we have a container. Okay, we have a beaker or a container you take. Okay, the partial pressure of ethane over a saturated solution containing 6.56 grams of ethane is 1 bar. Okay, he has given the partial pressure of ethane for us over a saturated solution. Okay, and he has given us the mass of ethane. Okay, mass of ethane. Okay, let me explain you. Now, when he has given us solution, we clearly understood the gas which is passed onto this into the solution is ethane. Okay, C2H6 ethane. Okay. So one thing is clear, the gas is ethane because here he has given pressure of ethane which is 1 bar. So the gas that is being passed is ethane. Now the partial pressure of ethane over a saturated solution containing 6.56 into 10 to the power of minus 3 grams of ethane is 1 bar. Okay, now he is saying that, okay, the partial pressure of ethane over a saturated solution containing in that solution, what is the mass of ethane? Okay, in that solution, what is the mass of ethane for us? Okay, in that solution, what is the mass of ethane? 6.56 into 10 to the power of minus 3 grams of ethane is the mass. Clear? Okay, so this is one condition he has given for us. Now, for this, and he has also given us pressure of ethane, okay, which is equal to 1 bar. Okay, I'll make it very simple. There is ethane, okay, there is ethane gas. Okay, they have passed ethane gas. Okay, ethane gas. Okay, obviously if nothing is given, I will take the solvent as water. Okay, I'll take the solvent as water, has been passed into water. Now, when ethane gas has been passed into water, the mass of ethane gas in this saturated solution. Now, we have passed ethane gas up to saturation. Means what? We have passed ethane gas to such a point that no more ethane gas can be passed into water. So this solution has become which solution? Saturated solution. This solution has become saturated solution. We started passing ethane into water till it has become a saturated solution. Now in this saturated solution, the mass of ethane. So ethane is now there in water. It has made a solution. Now the mass of ethane in this saturated solution is 6.56 into 10 to the power of minus 3 grams, and the partial pressure of ethane. The partial pressure of ethane here is how much? The partial pressure of gas is how much here? 1 bar. So this is one data given. Then he is saying that if the solution contains, okay, now he is saying this is one condition. Now he has given one more condition. Now I will take it as condition 1. Okay, I will take it as condition 1. Okay, I will take it as condition 1. Now he has given one more condition for us. He has given one more condition. I will take this as my condition 2. Okay. Okay, next condition is if the solution contains 5.00 into 10 to the power of minus 2, it should be grams, okay, minus 2 grams of ethane, then what shall be the partial pressure of the gas? Now it is the same thing, everything is same. Everything is same. I have water, okay, I have water. Into this water we have passed ethane gas. Okay, we have passed ethane gas. Now he is saying when they have passed ethane gas into water till the saturated solution is made. Okay, so now this solution is also which solution? Saturated solution. Okay, this solution is also my saturated solution. Now here, in the previous case, pressure of ethane has been given. Now in this case, pressure of ethane is not given. But he has given, now we have passed ethane into water, he has given mass of ethane in this saturated solution. He has given mass of ethane in the saturated solution. Now in this case, what is mass of ethane in the saturated solution? 5.00 into 10 to the power of minus 2 grams. So in the first case, ethane gas has been passed, okay, at a pressure, what is the partial pressure of ethane gas? 1 bar is passed into water. A saturated solution has been made. In the saturated solution, the mass of ethane is 6.56 into 10 to the power of minus 3 grams. In this condition 2, he didn't give us the partial pressure of ethane gas that has passed into the solution. But he has given mass of ethane gas which is there in the saturated solution, which is 5.00 into 10 to the power of minus 2 grams. Now our motto is to find partial pressure of the gas for the condition 2. Now, okay, here I'll teach you a special formula here. Mass of gas is equal to Henry's constant into pressure of gas. Please remember this formula for the questions where he is dealing with mass. Okay, and it is a comparison question. This formula will be of great help. It is a derived formula from our main thing. Okay, mass of gas is equal to Henry's constant into pressure of gas. Whenever you have only mass based questions, okay, then you can go with this formula and try to get whatever is required for the question. Mass of gas is equal to Henry's constant into pressure of gas. So here I want, okay, let me write the formula here. Mass of gas is equal to Henry's constant into pressure of gas. Now from this, okay, now what is the gas here? Ethane, no? So mass of ethane is equal to Henry's constant into pressure of gas, which is my ethane. Now here I have to find out partial pressure of ethane. Mass of ethane is given for me in the question. Okay, now if I know Henry's law, okay, if I know Henry's constant, I can easily find out pressure of ethane here. Pressure of ethane is equal to mass of ethane divided by Henry's constant. Now mass of ethane is already there given in the question for us. 5 into 10 to the power of minus 2 divided by, now Henry's constant we don't have. Okay, now Henry's constant we don't have. Now I need to find Henry's constant so that I can complete this calculation. Now how to get Henry's constant? Now we have some data given for this case. Okay, now you people think Henry's constant, I told you in the previous session also, Henry's constant will not change as long as the gas is same. Now am I altering the temperature here? No, I am not altering any temperature here. I didn't alter temperature, so Henry's constant will not change all through. Did I change the gas here in both the conditions? No. In the first condition, the gas was ethane. In the second condition too, the gas is still ethane. So Henry's constant will be same for this case and this case. Now, if I can find out Henry's constant from this case, I can use the Henry's constant here. Because complete everything is same. As long as gas is same, Henry's constant will remain the same. As long as the gas is ethane, the Henry's constant will be same. Now if I see here, okay, if I use this formula, I need Henry's constant here. Now Henry's constant is equal to mass of gas, okay, I'll directly write ethane, no? Okay, Henry's constant is equal to mass of ethane divided by pressure of ethane. Okay, now mass of ethane is given for this case, it is 6.56 6.56 into 10 to the power of minus 3 divided by pressure of ethane is given here 1 bar. So what will be Henry's constant here? 6.56 into 10 to the power of minus 3 will be my Henry's constant. Now I will take the same Henry's constant and I will substitute here because it is the same gas. Now what is the Henry's constant I got here? 6.56 into 10 to the power of minus 3. Clear till here? This data has been basically given to find out Henry's constant from this data and use the Henry's constant for the next calculation. So because the gas is same, there is no temperature alter, I have used the Henry's law because the gas is still ethane. Now if you calculate this, the answer will come out to be 7.62 bar will be your pressure of ethane gas. So in this case, what is the pressure of ethane gas? It is 7.62 bar. Clear? So please remember this formula. This is a derived formula. It will be useful for this kind of questions where you have to directly deal with mass. It will save your time in the examination. Hope you understood the calculation. Okay, there was one condition where ethane has been passed at a pressure of 1 bar. Okay, and a saturated solution has been made. In that, mass of ethane has been given. So using this data, we have found out Henry's constant. Now there is one more condition where ethane gas has been passed and a saturated solution has been made. The mass of ethane in this saturated solution is 5 into 10 to the power of minus 2 grams. But the partial pressure of ethane in this case is not given. So I have used Henry's constant from there. So pressure of ethane, the partial pressure of ethane gas is equal to mass of ethane divided by Henry's constant. When I have done the calculation, I got my answer to be 7.62 bar. Okay, so this is an NCERT exercise question. Hope you understood the hope you understood the whole process. Okay, clear. I did the questions from in-text and exercise for the Henry's law. Hope you understood them. If you have any doubts or if you want any information about the solving part, please put in the comment section, or any suggestions, please put in the comment section. Okay, in the next session we'll be seeing a different concept because we are done with solubility of solid in liquid. We are done with solubility of gas in liquid. We'll see a new concept in the next class. Till then, keep watching our channel, keep loving our channel. Bye.